Hi guys, today we are going to look at how to solve trig equations. I am going to, similar to the last couple lessons, I'm going to split this video into two different pieces just to cut down on the time. When we are solving, first thing we need to do is isolate the trig function, if we can. Now, why I made the comment of if we can and wrote if possible, if you got more than one trig function, you can't isolate the trig function because there's two different ones. Or if you have a trig function squared with a non-squared one, you can't isolate. When that happens, you may have to factor. Okay. Then, once we get our trig function isolated, or after we've factored, if we have to, then we're going to solve for the variable, theta, x, alpha, whatever variable is representing the angle. Now, with that said, remember, we're solving for the angle itself. So if you get down to like sine of theta equals square root of 2 over 2, that's not your solution. That's the point when you're going to ask yourself, when does sine equal square root of 2 over 2? And you're going to give me the theta values. So you're going to have to use your unit circle. Okay? All right, so this first example, it's kind of hidden just a little bit because I've got this function printed on here too. But I'm trying to solve 2 sine of x equals 1. Well, the first thing I need to do is isolate my trig function. So I got to get rid of this 2. I'm going to divide both sides by 2. Now, thinking about my unit circle, I'm going to figure out when does sine equal 1/2. Okay, and so I'm going to carry this unit circle around from problem to problem. Okay. Oops, I forgot to write my pi over 3. My pi over 2. Okay. So I made a very small, very sloppy unit circle right there. So now I'm going to ask myself, when does sine equal 1/2? Well, there's one of them at pi over 6. But that's not the only place that sine is positive or 1/2. That would happen here as well, which is at 5 pi over 6. Now, the purpose of this graph that's kind of just slapped here in the middle of my notes page, and you're like, what's this for? This sine curve goes on and on forever. Same with cosine curves. They go on and on forever. I've only listed 2 solutions. There's actually an infinite number of solutions on all of these problems. And it has to do with the fact that the sine curve keeps repeating and repeating and repeating. How often does it repeat? And look, we had 1/2. There's 1, 2, 3, 4, so on and so forth. And they're going to keep going and going and going. So we already listed these 2, the pi over 6 and the 5 pi over 6. But look at what happens. How do I get from this solution to the next one? That would be 1 full circle. Okay, if you want to visualize what I'm talking about. Here's pi over 6. I can rotate 1 full circle and get another answer by adding 2 pi. But then I could do that again and again and again and again for as many circles as I want. So anytime today when we are solving these, today and technically tomorrow, to take our answer from one solution to all of the solutions, we have to add the 2 pi in. 4 trig functions that have a period of 2 pi. They don't all have a period of 2 pi. Sine does, as well as cosine, and they're reciprocals. Secant, oh, can't spell secant. And cosecant. But what about tangent and cotangent? What are their periods? They only have a period of pi. So when we solve a tangent or a cotangent function to get the infinite list of solutions, we're going to write plus pi in instead of plus 2 pi in. Okay. All right, isolate the trig function. Well, I've got 2 different ones, so first thing I've got to do is get them together. So I'm going to subtract sine x from both sides. A negative 1 sine minus 1 sine would be negative 2 sine x. Trig function's still not isolated yet, so I'm going to divide both sides by negative 2. So now I have that the negative square root of 2 over 2 is equal to sine. So now we're going to think about our unit circle. Square root of 2 over 2 happens here at pi over 4. So that means a negative for sine. Sine goes negative in quadrant 3. What pi over 4 is that? 5. So x equals 5 pi over 4, but I'm going to tack on the plus 2 pi in to give me every possible solution at that mark. Sine is also negative here in quadrant 4, which would be 7 pi over 4. And then we're going to put on our plus 2 pi in. All right. Try a tangent. I've got to get the trig function by itself, so first I'm going to add 1 to both sides. Now I'm going to divide by 3. I kind of have my trig function isolated, but there's still that squared. So to get rid of the squared, I'm going to square root both sides. But remember, when you square root fractions, you can just square root the numerator and denominator separately. Square root of 1 is 1 over square root of 3. Make you rationalize, we get square root of 3 over 3. So where does tangent equal square root of 3 over 3? That happens at pi over 6. But since it's tangent, tangent's period is only pi, so we're going to go plus pi in. Tangent is negative in quadrant 2, but then it's positive again back in quadrant 3. So here at 7 pi over 6. Okay. I'll do one more example, and then on the next video I'll do the final 3. This question here is one where we're going to have to factor. I know that because I have 2 different trig functions, so I'm probably going to have to do some kind of factoring. And in order to factor, our equation has to be equal to 0. So that's what I'm going to do first, get this equal to 0. Now that it's equal to 0, I see that both terms share a cotangent x. So let's factor cotangent x out of our problem. How this works to my advantage is now I've separated the two trig functions and I can treat them like two different problems. So I'm going to set cotangent of x equal to 0, and I'm going to set cosine squared x minus 2 equal to 0, and I'm going to solve them separately. Cotangent is not something that we have memorized from our unit circle. However, we should have its reciprocal memorized. So if cotangent is equal to 0, its reciprocal tangent would be 1 over 0, which is undefined. So my unit circle, let me bring it down here. When is tangent undefined? Well, I know tangent is 0 at 0. Tangent is undefined up here at pi over 2. And then get our infinites by adding plus pi in. And then where else is tangent undefined? At the other vertical, 3 pi over 2. Plus our pi in. Now we're going to go over to the other trig function and we're going to solve it. I'm going to add 2 to both sides. And then I'm going to have to square root to get rid of the squared. But cosine equals square root of 2. Well, at pi over 4, I know it equals square root of 2 over 2. But is there anywhere on our unit circle where cosine is just the square root of 2? There is not. So there's no additional solutions that are going to come from this answer. Okay.